Radio wave transmission.
Today, we are going to learn about radio wave transmission. It starts with the microphone. So when I'm holding the microphone converts my sound into an irregular electrical signal. Looks like this. With a radio tower next to it, I cannot send this irregular signal. I just cannot broadcast it. Okay? So because if I broadcast it, and the people have no idea how to receive this kind of signal. There are natural occurring radio wave signals around the earth all the time, and a single signal like this is just unidentified from the natural occurring random radio wave signals. So what I need now is a modulator. Now, a modulator, what's happened is a modulator combines the signal wave, the original signal wave, with a standard high-frequency carrier wave. Normally, a standard high-frequency carrier wave is generated from a RF radio wave generator. And it looks like this. I'll show you a detailed example later. And what does the modulator do? The modulator combines these two waves together. Say if the standard wave is 100 kilohertz. Then after combining them together, the combined wave is going to be 100 kilohertz. The reason we do that is, then if we broadcast the whole combined wave, in the receiver tower, they can set up their machine to receive radio waves of only 100 kHz frequency. Thus, the signal gets transmitted through radio. Okay, now have a look at this. Okay, sorry. Now have a look at, actually I show you what's happened there. Now have a look at a signal wave. Okay. Say I generated this irregular random wave. Okay. Say this is a signal wave. Say if I talk like a machine, then I record this kind of wave. Okay. Then because the frequency of this wave is kind of different, it's quite different. Okay, it goes up and goes down, and it goes longer. Some distances, some tips are longer, some tips are shorter, and this wave contains various of different frequencies. Okay, so if I try to broadcast this wave, the receiver tower has a on the other side, when people set up receivers, they have difficulties because there's so many different natural occurring radio waves in nature, and they have no idea which frequency to look for to pick up this signal. So what we do is we combine it with a standard wave. We call it a standard carrier wave. It looks like this. So it's a wave of a high frequency and the same amplitude like this. So when I combine them together, it looks like this. That's when they combine together. You see, the amplitude changes. The amplitude goes up and goes down. However, the frequency of the wave doesn't change. So, if the receiver machine Okay, setup is receiving frequency to this certain frequency of the standard wave, the carrier wave. They can receive this signal. Okay, then the signal get transmitted. Okay, I show you the original signal again, just to have a look. So the original signal looks like this. Okay, looks like this. It goes up, goes down a little bit. Okay, we can do a check. It goes up at around 1, goes down a little bit, then goes up. So what's happening is if I combine this with the standard wave, okay, they look like this. Okay. It goes up, then goes down, then goes up, then goes up, goes down, goes up, goes down, then goes up again. Okay. The trend here follows the signal wave. Okay. Now, so okay. Okay, now if after the signal has combined with 100 kHz standard carrier wave, it being broadcast to a radio tower. With a radio antenna, if I set up the antenna to receive the signal of 100 kHz, okay, it will receive the combined signal. That's what's happening is in your car when you drive your car, when you listen to your radio, you see those um, AM and FM channels. So AM is basically for amplitude modulation. FM is stand for um, frequency frequency modulation. Now, what I showed you before with the carrier wave, what I showed you, the combined signal here, is this is an example of amplitude. This is an example of the amplitude modulation, because you can say from the amplitude we can see a trend. Okay, we can see the trend of the original signal. Okay, so every time you go to the you listen to those AM channels of say 101.1 channel 101.1, so that's basically 101.1 kilohertz. Okay, that means this channel is broadcasting on 100.1 kilohertz. Every time you turn the radio button in your in your car, you basically adjust the receiving frequency of the antenna. Okay. So if the receiving frequency of the antenna matches with the broadcasting channel frequency, you receive the combined wave, the modulated combined wave, the AM channels. The FM channel is another story, but the idea is they do something. There's still a process of modulation, means combining the waves of the original, combining the signal with the carrier wave. And afterwards, after the antenna received the combined wave, it goes through this. It sends the signal to a demodulator. Okay, the demodulator this time is working well. It's like an inverse as a modulator. Okay. It separates the carrier wave from the combined wave and just obtaining the original signal. Okay. Afterwards, the original signal is sent to the speaker. Then we are able to listen to the broadcast. Okay. Listen to the radio program. So this is the concept, the basic concept of how radio wave transmitted. Now, in year 12, okay, the important thing you need to be able to do is you need to be able to understand this process, okay, especially Okay, you need to be able to explain the process of modulation. Okay, just let me mark it. Okay. So if they ask you what is modulation, you need to be able to write this down. Okay. Also, you need to be able to answer what is demodulation. Yes, and don't worry too much about AM and FM. They all, well, they all modulations. So I gave you an example about amplitude modulation. For frequency modulation, it's the same thing. It's basically, well, the the concept is a little bit different, but the theory behind it is the same. It's always we have a signal, we have a carrier wave, we combine them, then we transmitted it. Okay. Then on the other hand, on the other side, when we receive the signal, okay, we take away the carrier wave, leaving only the signal, okay, to the speaker or to wherever the machine is. Now, the other thing I want to show you is about your internet modem. Now, your internet modem, okay, is a short form. Okay. The full form is modulator and demodulator. Okay. So modulation and demodulation involves not only in radio wave transmission, even in digital transmission. For instance, whenever I want to send something to the internet, I type it in, and I type it in computer. The original signal has been modulated with a carrier wave, has been combined with a carrier wave sent to the internet. Then, well, say if I write an email, when you received my email, your computer, basically your modem, received the combined wave. Then your modem demodulate it, then leaving you the information, then you can read my email. So just remember today, okay, modulation and demodulation just make information transmission much efficient and effective. Okay. Almost all the information, digital information transmission or analog information transmission involves the process of modulation and demodulation. Okay. Just remember your modem, a modulator and demodulator. Okay. Now,